Welcome to the Curious Data Explorer channel. My name is Ashraf and I'm an experienced data practitioner. The focus of this video is responsive menus for web pages and applications using TailwindCSS utility classes. We'll build a menu that is suitable for both desktop and mobile use, including dynamically changing the menu symbol from the classic hamburger to a cross, all without JavaScript. Furthermore, we'll illustrate the key supporting principles and the right behaviors required for validation. The scope is to build a responsive menu system for a web application or site. Primarily, we'll be using the Flexbox concept from Cascading Style Sheets, accessed through the Flex Tailwind utility class. There are three key principles that support this menu system that mean we can avoid the use of JavaScript and keep the overall application snappy. The first combines the checkbox input tag peer class and its modifier peerChecked. This enables a sibling or peer, which is defined as two elements that have a common parent, to react to a change in state in the target element. We'll use this to make the navigation links visible when the checkbox is activated. The second provides a HTML native method to trigger a change in a peer element applicable between an input tag and its label. Specifically, we'll illustrate a design pattern that combines the for attribute of the label. The third illustrates how the child elements can react to an interaction in their common parent using Tailwind's group utility class and subsequent modifiers. We'll also illustrate a lesser-known combination of the peer and the group classes that allows us to dynamically change the mobile menu icon. Looking at each of the principles in turn, the first is the use of the peer utility class and its modifier peerChecked. The example code shows two tags, an input of type checkbox and a div that contains the navigation links. The input tag has the class peer, whereas the div by default is hidden using the namesake class and uses the peerChecked modifier to become unhidden using the block class. The figure on the right shows the effective relationship between the elements. In this instance, both the input and div tags have a common parent tag called header, making them both siblings or peers of each other. The utility class peer is then used to capture actions performed on the target element to which its peer can respond. In this example, when the checkbox is activated, the div becomes unhidden, showing the navigation menu. The second principle is a HTML native mechanism that replicates the behavior of Tailwind's peer class but applies to specific HTML tags. The example code shows two tags, an input of type checkbox and a label that contains the mobile menu button, typically a hamburger menu icon. The input class has a unique ID, in this instance, menu toggle. The label tag contains an attribute called for, which identifies the input element that the label is applicable for. It contains the ID from the input tag. The figure on the right shows the effective relationship between the elements. Much like the previous example, both the input and label tags have a common parent that makes them siblings or peers. And much like the utility class peer, the HTML native relationship between these elements using the for attribute means that an action on the label is in effect forwarded to the checkbox. In practice, it means that when the hamburger menu is clicked, it activates the checkbox. To complete the example, note that the checkbox has the class hidden as it has been replaced by its label. The final code principle combines Tailwind's peer and group utility classes in transmitting the change in state of the checkbox to change the hamburger menu symbol to that one of a cross when the menu is open. The example code shows the same two tags as before, but includes one of the two icons, in this instance an SVG. The input tag utilizes the peer utility class and normally would enable its sibling or peer elements to respond to the activation of the checkbox using the peerChecked modifier. As illustrated previously, the modifier is only applicable to peer elements only. To transmit the change of state to the child elements of the label, we can couple it with the group class. The end result is a little bit counterintuitive in terms of the class definition on the SVG. The outcome is to hide the hamburger symbol when the checkbox is clicked, using the hidden class, and when the mobile menu is open, whilst displaying the cross SVG instead. The trigger is using the group class to receive all actions from the parent label using the empty square brackets and then respond to the parent's peer checkbox activation. If you found that confusing, the figure on the right shows the effective relationship between the elements. The input and label tags are peers and the SVG is a child of the label. The SVG cannot respond to a peer modifier such as peer checked from the input. To overcome this, applying group to its parent and using the universal group modifier, the SVG can now respond to peer signals received by its parent. This video is based on a blog called Responsive Menus with TailwindCSS at the home of the Curious Data Explorer channel. You can access this from the URL provided or using the QR code. We tailor our content for a variety of mediums, from blog posts to podcasts to this very video. So it's worth reading the blog post in addition to this video for more of the finer details. If you find this guide or any of our content useful, then please engage with us with a comment, like, or by subscribing. Most of all, tell a friend. My name is Ashraf and I'm a Curious Data Explorer. Let's now begin the guide. The starting point is a HTML or hypertext markup language document, which consists of a document type declaration at the top, a HTML tag with a language attribute specifying the English language. Within a pair of head tags, we have two meta tags. The first sets the character encoding of the document, in this particular case UTF or Unicode. The second resets the behavior of mobile web browsers, which automatically scale desktop sites. This ensures no scaling occurs, as we will be managing the site experience directly using a responsive menu system. On line 7, we have the title of the web page, and on line 10, we use the Content Delivery Network or CDN installation method for the Tailwind CSS library. On line 13, we have a pair of empty body tags. The output of all of this is, in effect, a blank page. Let's begin with some dummy content. Within the body tag, we include a set of header tags. Semantically, the menu sits as part of the header of the document, and that will be the focus of this tutorial. The second part is some example content, which consists of a level 1 header and a paragraph with some example text. If we save the document, it produces an output, and this will provide some context for the menu that we'll be developing. For the header, we set a background color of dark blue and a default text of text gray 300. The header consists of 3 parts. The first is the logo, an outer div, followed by a link, which consists of an image file and some text. If we save this, we can start to see the beginnings of our desktop menu. The second part is the menu. This again contains an outer div. Semantically, we're going to provide a navigation, so we use the nav tag, which consists of unordered lists using the UL tag. There are 3 list items specified by the li tag, consisting of links targeting home, our team, and about us. If we save, we can start to see that all of the text is left aligned and stacked on top of each other. The final element is a call to action or CTA button, consisting of a link and a button tag with the words contact us. If we save all of those elements, we can see on the right hand side that each item is stacked on top of each other. The key to our desktop menu is the use of the Flexbox Cascading Style Sheets or CSS attribute. To begin with, we'll focus on the header tag. First of all, we'll specify flex. Now by default, the Flexbox is row orientated, and in my view, it's helpful to make that explicit. So we'll add flex row. Secondly, we'd like all the items to be vertically centered. So we'll use the term item center. And finally, add some padding. This aligns the 3 elements horizontally in the row direction, but as you can see, they're in close contact and quite look like a desktop menu. The intention is to have the logo and associated text on the left-hand side and the remaining elements pushed to the right-hand side. There's a number of ways to achieve this, but one of the methods is to use the flex1 utility class. This class means that the logo element will consume all available free space. In effect, pushing the other items to the right-hand side. The next step is to put the logo next to the logo text. Again, we use flexbox to specify flex. By default, the orientation is row, so we specify the term flex row. We want to vertically center the item, so we use item center, followed by a gap of 2 and vertical padding of 2 as well. We reduce the size of the symbol using the h10 class. The next step is to modify the menu. Again, we use flexbox, so specify flex. By default, it's row orientated. We want to center the items vertically, so we use item center. We want to separate the two items out, so you use the term justify between, with a gap of 4 and a padding of 4. The result looks closer to a menu which is vertically aligned. The third element is to make the button, the call to action button, look like a button. Let's start off with a bit of background so we can see the changes that we're making. To give the item its button shape, we'll add some horizontal padding, some vertical padding, change the font weight to medium, change the color to text gray 200, and add rounded corners. For interactivity, let's add a hover effect. We change the text to white, and we change the background color to something lighter, BG Sky 500, which we can see changes as we hover over the button. At this stage, we have a realistic looking desktop menu. The desktop menu requires a tiny bit of polish. First of all, let's add a hover effect to the symbol using hover and scale 105, which increases the scale by 5%. For the text itself, let's make a number of modifications. We've converted the text to uppercase, we've increased its size, we increased its font weight. On hover, the text turns to white. There's an underline effect, and the underline offset is 4 pixels. To see that in effect, let's move our mouse over the logo. We can see it increases by a small margin. Likewise, let's hover over the text, and we can see the underline effect. What we want, however, is that when we hover over one feature, we want both features to be interactive. This can be achieved using Tailwind's group class. There are 3 changes that have been made. The first is on line 18, we've added the group class. This is the parent element to both the image and the span tag containing the root insights text. For the image, we've changed from hover to group hover for the scale 105%. Likewise, for the text, we've gone from hover for the text color change, the underline and the underline offset, to group hover. The impact of that is that now if we hover over the text, the symbol increases in size, or if we hover over the symbol, the text has an underline. This is the principle of the group CSS class. The next task is to look at the same web page using a mobile browser. In this particular case, we use an iPhone 12 or 13 viewport. As you can see, the text has overlapped. We have a menu items overlapping and text wrapping occurring for each menu link, as well as for the button itself. To help us focus on the key issues, let's first of all hide the navigation. Having hidden the navigation, we can see that the logo and the symbol are a little bit large, as is the button itself. So we can make some minor modifications for the medium breakpoint using the MD keyword. To make the header more mobile friendly, we've made two key changes. The first is, as Tailwind is a mobile first utility framework, we specified a height of H8. At the medium breakpoint, we go back to the original H10, which we use for the desktop. For the text, for mobile use, the size is text XL, and for medium breakpoint, text 2XL. And finally, for the call to action button, the default text size is text SM for small. At the medium breakpoint, it reverts to text base as used in the desktop menu. If we unhide the menu again, we can see the challenge before us. The three menu links are cramped between the logo on the left and the call to action button on the right. To start to address the challenge with the menu, we can start by using the Flex Wrap class. Applying on the header pushes the final element to a new line, which is similar to what we want, because we want the menu items to sit below the logo and the call to action. But to do so, we need to change the order of things. We really want the call to action button to in effect be in the middle of the three sets of elements. To do that, we need to move the button physically on the DOM, the document object model. The call to action button has now been moved to line 33, and we can see that the menu, the mobile menu, is starting to take shape. The next step is to change the orientation of the navigation menu from being row-wise to column-wise. One mechanism to implement this is to, in effect, only enable Flexbox at the medium breakpoint. This has the effect of stacking the three menu links together. The second change we wish to make is to make each item, menu item, full width. This would force it to sit below the remaining text. We can do that on the div. But that means for the medium breakpoint, we just set the width to be automatic. Now it's starting to look more and more like the mobile menu. There are two issues with the current layout. The first is the logo and the menu links no longer align, and the links are lacking some basic effects. The first step is to disable the padding. The second step is to modify each link. Each link now has a hover effect in the desktop menu, including white text, underline effect, and underline offset of 4 pixels. As this is a mobile first utility library, we enable block. We add some, by default, vertical padding of PY3. By the medium breakpoint, we remove that. The effect of that is to provide a bit of spacing and some uniform width. Now that the mobile menu looks appropriate, we need to trigger the menu, and to begin with, we'll use a checkbox. To trigger the menu, on the checkbox, we've applied the class peer, which means correspondingly, on the div for the menu, we can respond with peer checked. In this instance, when the checkbox is clicked, we'd like the element to have a block layout. Otherwise, by default, to be hidden, but the medium breakpoint to also be block. This makes the menu disappear, such that when we now check the checkbox, it comes up. If you click on it, it deactivates. So we now have a dynamic menu. There are multiple methods to remove the checkbox. One method is to hide it, which is what we intend to do. The second is people tend to put a menu icon on top of the checkbox. So by clicking on the menu icon, they inadvertently click on the checkbox as well. As we're going to do the former, We'll add a mobile menu button. To do so, we'll use the label and for attribute to selectively choose the same ID. So on line 45, that's what we have. We also add a cursor, pointer, and some left margin. Within that, we have a hamburger menu taken from open source. When we save, we can see the menu appear on the right-hand side. If we now click on this, it checks the checkbox and it opens the menu. We can now hide the checkbox using the hidden class, leaving just the menu icon. Next, we add the close icon. This is a cross SVG. Please note that by default on line 17, we have hidden the cross icon. If we save, this has zero impact on the output. We can't see it. This is where Tailwind utility classes, both the peer and the group, are combined to allow us to dynamically change the icon based on the state of the checkbox. The first thing to do is to add the group class to the label. Secondly, we want the hamburger menu to disappear once the checkbox is clicked and it's affected by the group. So on line 53, we add a peer check pseudo class, which is grouped to match any response. And the result of that is then the hidden class. So in effect, if the group itself is toggled, the hamburger menu is hidden. For the close icon, we have the reverse. The close icon goes from hidden to block. If we now open the menu, we can see that the symbol has dynamically changed to a cross. It's not possible to animate an element that goes from hidden to block. What we can animate is the height. So rather than having these utility classes, we can change them for a default height of 0, and then when the checkbox is checked, a height of 36. If we now click on the menu, we get exactly the same effect. But the fact that the height is changing means we can now start to animate it. The second observation is you can see here the links are visible. We need to curtail this using overflow hidden. At the same time, also add a transition. To clip the text, let's add overflow hidden. Followed by some transitions. Transition all, a duration of 300 milliseconds with a delay of 150 milliseconds. This provides a very smooth animated effect. We now have a complete mobile menu with a functioning setup. But having made some structural changes, what does it look like in terms of the desktop menu? The desktop menu now no longer seems appropriate. We still have the hamburger menu visible. We have the call to action button, but in the wrong place. The navigation bar is missing. So to rectify those, we need to modify the menu at the medium breakpoint. The first step is to hide the hamburger menu at the medium breakpoint with MD hidden. The second is to have a default height at the medium breakpoint of H auto. So medium breakpoint, H auto. The remaining issue is but the call to action and the menu items are in the wrong order. We want the call to action in the desktop menu view to be on the right hand side. We can do this using the order classes. So in this case, we want the menu to come first. So at the median breakpoint, we can add order 1. That alone will have no changes without corresponding change to the call to action button. On the call to action button, we add at the median breakpoint, add order 2. And that changes the default order for the median breakpoint. And now we've gone back to our original desktop menu. And to confirm that nothing has broken, we can reactivate the mobile view to ensure that no adverse effects have occurred. In this case, we've got a fully working menu with the call to action button next to the hamburger menu. And if we go back to desktop menu view, we've got the links in the order that we wish them to be. We demonstrated in this video how to create a responsive mobile menu for a web page or application using TailwindCSS. Beyond the code, we showed you 3 key principles that enable a menu system that can dynamically change the mobile menu icon from a hamburger symbol to a cross, all without JavaScript. In addition to demonstrating the utility of the Flexbox CSS concept, we illustrated the effect of using the peer class to show the navigation links when a checkbox was activated. We used a native HTML peer type relationship between an input tag using its ID and a label tag and its for attribute. This enabled us to hide the checkbox and instead trigger a response using custom SVG icons within the label tag. Finally, we combined Tailwind's peer and group class together to dynamically change the state of a child element when its parent received a response from a peer. All that remains is for me to thank you for watching. If you found this video useful, please engage with us with a comment, like, or by subscribing. Most of all, tell a friend. Thank you again for watching. My name is Ashraf, and I'm a curious data explorer.